Okay, guys, I must really love you because I just made a 50-minute long study guide video, and here we go. 10.4 notes. I know you have a sub, so some of you said that you wanted a video also. Okay, so perimeters and areas. So we're talking about perimeters and areas of similar figures. We have talked about similar figures before. Whoa. Okay, so reminder on similar figures. They are the same shape. They are just different size. Okay, so they're corresponding angles, like you see down here, right? Two lines and two lines. They're congruent. And their sides, ooh, it sounded like a granny, sides, um, are proportional. Is it funny that every time I write that word, I always have to think about it? Proportional. Okay, and let us not forget our friend scale factor. You will see K, and I don't want you to wonder what that is because that is the scale factor. Okay, so let's just go ahead and I'm going to highlight the corresponding angles here. The light and color is not very good, but hopefully you can kind of see what I'm doing. All right, two separate problems though, but I'm doing them at the same time so that this video isn't another 50-minuter. And I guess purple for this one. Okay, so what I've done is I've gone ahead and I've marked all the corresponding sides. Now it says determine if the polygons are similar. If so, write a similarity statement and give the scale factor. So we will write K if they are similar, and we'll write our scale factor right here. So if you notice all the corresponding sides between turquoise and pink, 4 and 6, between pink and orange, 4 and 6, 4 and 6, they're all 4 to 6. So that means when I'm looking to find my scale factor, I only have to pair up a 4 and a 6. Okay, and then I can reduce them. They're both divisible by 2. So this becomes 2 and this becomes 3. That right there is my scale factor, 2 over 3. My similarity statement is A, B, D, C. That's just the order I went in. I just went clockwise. So A, B, D, C is similar to, well, I have to go in the same order. Since I started with turquoise, I have to start with turquoise here. So D, E, because I went to pink next, down to orange, F, and then ending with purple, G. That's my similarity statement. Okay, next up, this one is a little different because you notice the sides aren't like 4 and 6. They're not like 16 and 8, 16 and 8. It's not the same. So what I'm going to do is I'm going to start with my smallest side, which is 8. I'm going to find my other smallest side over here, which is 16. Okay, I'm going to reduce that if possible. Hold on one second. My lights just turned off. Okay, so those are both divisible by 8. So that would become 8 divided by itself is 1. 8 divided by 16 is 2. All right, so now we just want to make sure that all of the sides simplify down to 1/2. Then they would all have the same scale factor. So now I'm going to move to my medium size, which is 15. And that gets paired up because that's between a turquoise and an orange. Between a turquoise and an orange is 30. Ooh, look at that. That also reduces to 1/2. And my last one is 17 and 34. Well, that reduces to 1/2 as well. So my scale factor is 1/2. Okay, now I can write a similarity statement. So triangle PQR, PQR is similar to, well, I have to start with J because I started with turquoise here, or the square. So triangle JKL. So going to pink to orange, just like I did in that previous triangle. Okay, so it says find the perimeter and area of both triangles in number 2. So we're going to focus on these triangles. So we're going to do the perimeter, or we'll do the small triangle first. And we'll find the perimeter, which means we're just going to add up all the sides, which is going to be 15 plus 17 plus 8, and that will give us 40. Okay, now we're going to find the perimeter of our large triangle. All right, so perimeter is going to be, I'll just box that for now. Perimeter is going to be equal to 16 plus 34 plus 30, and that will equal 80. Okay, so $40 and $80. Now let's find the area. Well, the area for the smaller triangle, remember, is base times height. So 15 times 8 divided by 2, that would be 120 divided by 2, which would be 60. So that's our area. Our area for our bigger triangle is going to be 30 times 16 divided by 2, which would be 480 divided by 2, which would be 240 centimeters squared. Oops, I forgot to write that for that one. Oh, and I forgot to box these in. Wow, I'm just a mess. Okay, so what I want you guys to do is compare. I'm going to set up a little scale factor with the perimeter. So we're going to say P for perimeter. I'm going to do the smaller triangle on top, 40, over the larger triangle. All right, and they're both divisible by 40, so that reduces to 1/2. And now we're going to look at the area. All right, area for the smaller triangle is 60 over 240, which reduces to 1/4. Okay, so hopefully you guys can see this. The perimeter is 1/2. The area is 1/4. When you think about perimeter, remember, you're just adding up all the sides, right? And let's say we were to write it like in terms of centimeters. This is centimeters squared. This is just centimeters. This is just centimeters, right? It's just one dimension all the way around. Okay, when we get to area, it's centimeters squared. Well, isn't 2 squared equal to 4? Keep that in mind when we're working with scale factors. Okay, perimeter is just going to be straight up normal. Same with regular scale factor. When we think area, we're thinking squared. Okay, so scale factor of 2 similar figures is simply just A over B. Perimeters, also just A over B, right? Just one dimensional, just walking a straight line around the soccer field. Or ratio of their areas is that A to B, but each of them are going to be squared. All right, so that's every spot, the length and the width inside that soccer field. Okay, well, Mrs. Black, what the heck are you talking about? Okay, let's start by doing some example problems, and I think it will make a bit more sense. So the figures below are similar. Well, that's perfect. What is the ratio, smaller to larger? So we're going to do our smaller on top of their perimeters and their areas. So first up, we're going to do perimeter. I'm going to go ahead and do smaller on top and larger on the bottom. I'm going to see that they're both divisible by 6, which makes this 1/2, right? 6 divided by 6 is 1. 6 divided by 6, 12 divided by 6 is 2. So 1 over 2. Remember, for area, I have to square it. So I end up with 1 over 4. Okay. Same idea over here. I'm going to do 4 over 7. Well, there's nothing for them to reduce to, so that's just going to stay 4 over 7. All right, but then when I think area, I need to square it. So square it, and I end up with 16 over 49. Okay, you guys pause me for a minute and try number 7. Okay, hopefully you got number 7. We can check this answer in class. Okay, number 6. Well, let's read the directions. The figures below are similar. Yay! Use the given area of the indicated figure to find the area of its smaller figure. Okay, what? All right, well, first things first, just be like, okay, I know the area of my smaller rectangle. Okay, that's great. I want to find the area of my larger rectangle. So we know this is 72. We don't know what that is yet. I'm going to do 6 over 9. I'm going to reduce it. They're both divisible by 2. That's going to become, they're both divisible by 3. That's going to become 2 over 3. Remember, because it's area, I need to square it. So I end up with 4 over 9. Okay, since I am now in a scale factor of squaredness, I can take my area, which is squared, and I can solve for my larger triangle. So because I had my smaller triangle on the, rectangle on top, I'm going to have my smaller rectangle on top over here. And this will just be x. I'll cross multiply for x and cross multiply 9 times 72 and get 648. I'll divide by 4 and divide by 4 and get x equals 162 meters squared. Not too bad, right? Okay, let's try number 9. We are going to do, it says the area of our larger triangle this time is 75. We're going to need to find the area of our smaller. So let's start with our scale factor. 2 over 5. I can't simplify it, so I'm simply going to square it. And I'm going to get 4 over 25. Okay, 4 over 25. 4 over 25, I'm going to set it equal x on the top this time because that's my smaller one, and 75 on the bottom. I'll go ahead and cross and multiply, which I don't have this one done, so give me a second while I have 25x and then 280, is it 310? Hold on, the calculator won't turn on. Times 75 equals, just 300. And then you divide by 25 and you get x equals 12, or the area for this triangle is 12. Okay, you guys give 8 a shot. And I want to see this answer in class. Okay, the area of a regular nonagon, which I'm not going to draw, is 34 meters squared. What is the area of a regular nonagon with sides 5 times the sides of the smaller? Okay, so it would be 5 times as much, right? So our OG nonagon is 1, right? And then we go 5 times the size for our bigger one. So this is our OG and this is our 5 timer. Okay, we know that our OG nonagon is 34 meters squared. We don't know our larger nonagon. So this is how you would set it up. 1 over 5, because 1 and then 5 times as much, equals the area of that original one, the OG one, 34, over x. So 1x equals 34 times 5, and x equals 850 meters squared. Okie doke. Let's do, I think we're going to do all of these. The longer sides of a parallelogram are 6 feet. So I have one parallelogram and its longer sides are 6 feet. The longer sides of a similar parallelogram are 15. So it's going to be a bit bigger, right? The area of the smaller parallelogram is 27. What is the area of the larger parallelogram? Let's figure that out. Okay, we're going to use their sides as scale factors. So 6 over 15, well, that can reduce, right? Which they're both divisible by 3, so this becomes 2 over 5. Divide by 3 is how I got that. And then we remember we need to square it because we're talking about area. So that's going to be 4 over 25. Now they gave us the area of our smaller one, which is 27, but they want to know the area of the larger one. So we're going to say that's x. All right, we are going to cross multiply. For x equals 25 times 27, which is 4x equals 675. We'll divide by 4 and divide by 4 and get x equals 168.8 feet squared. Okay, the shortest side of a pentagon is 4 centimeters. The shortest side of a similar pentagon is 9 centimeters. I actually feel like you could do this one without me, but maybe not. So, shortest side of a pentagon is 4 centimeters. The larger pentagon is 9. Okay, these can't be simplified. All right, so we are going to square them because, again, we're talking area. Area of the smaller pentagon, though, which is going to be 16 and 81. Okay, we're going to pair that up with what we know. So 16 and 81, we want to know the area of the smaller pentagon, so that will go on top with our smaller side. And we know that the bigger one is 243. So we're going to cross multiply, and we'll get 16 times 243 equals 18x, or 3,888 equals 18x. We'll divide by 18, divide by 18, and get x equals 48 centimeters squared. Okay, hold tight 1 second. There's a homework problem or classwork that I want to go over with you. This is number 10. You guys will be doing odds, so this won't matter to you, but it says the ratio of perimeters for each pair of similar figures. Find the ratio of perimeters, similar figures. Compare smaller to larger. Well, I don't know if you notice, but this is given to you squared already, which means that it's already your area. It's already in terms of area. So what we're going to do is we're going to figure out the scale factor. Okay. And let's see really quick. 50, oops. These are both divisible by 2. Wow, I don't know why that was so hard for me to see. End of the day. 36. Okay, but remember, these were in terms of area, which means they were already squared. So you need to think opposite of squaring something is square rooting. So you're going to take the square root, which is going to be 5 and 6. Okay, so that is your answer because it says find the ratio of perimeters. Well, we simplified what they gave us. Then we took the square root of it to turn it into typical terms, and we know, well, that k is equal to 5, 6. You are going to do the same thing for number 9. All right, that is it. I will see you guys soon. Have a good rest of your day. Adios.